Oh, look who's here. Harry. Should he get a cookie? Should he?
Yes.
Okay, he should. Take a cookie. Now, let's start looking at this one. I'll get it. Oh, I'll get a start on it.
Version 1? Version 4.
1718 version 4. Okay, let's have a look at it.
So, B1.
Yeah. Zach, I'll need you to read the question, so we'll have a look at it now.
Okay.
Right, go ahead, let's do this one.
A ball of mass.
Oh, hang on. What the heck? Come on.
I think the TV's on. Oh, it is on.
Oh, this one. And it's plugged in. That's not the issue. Oh, come on.
There you go.
Oh, great.
Why?
Right.
Off center.
Doesn't matter. Go ahead.
A ball of mass 0.55 kilograms is thrown vertically downwards with an initial velocity of 5.25 meters per second.
Right, let me write that down. 5.25 meters per second.
From the top of a tower towards the ground,
Yeah.
30.5 meters below.
Okay.
So these are just Suvat balls.
Yeah.
Question 1. Determine the velocity of the ball just before it hits the ground.
And is there the time as well they want?
No time. Yeah, on the next one.
Okay, so it doesn't really matter about the order. So V equals U. Oh no, I can't use that one because I don't know the A. V squared,
Okay.
I mean the T, sorry. V squared equals U squared
Plus 2.
plus 2AS. That's 30.5. They want the velocity. So after you get the answer, you want to square root it, and we'll take the negative answer. Is that with the square root?
Yeah, root. Check, Dory.
Sorry, I just started.
So 25.0 then.
25.02.
Okay. And the second part you said is what's the time, is it?
Mm-hmm.
So that's V equals U
Yeah.
plus A T. So T is 25.02 minus 5.25 over 9.81. So what's that, about 2-ish seconds?
2.015 seconds.
Yeah.
2.02 seconds.
Next question. Determine the kinetic energy of the ball.
Oh, really? That's
Yeah, this
okay,
is
sorry.
easy.
This is easy peasy. Right, well, the kinetic energy then is a half, what was the M? 5.5, wasn't it?
0.55, yeah.
So 0.55 over 2, 25.02 squared. Easy peasy.
172.1. Well,
172.15. So 0.2.
Yeah, well then 172 joules. Okay, next.
Explain why, in practice, the kinetic energy is.
Well. Look what the cat dragged in. Hold on. Take a cookie.
Oh, thanks.
Okay, sorry Zach, go ahead.
Explain why, in practice, the kinetic energy is likely to be slightly less than answering property. Air resistance.
Air resistance, so some energy is converted
To heat.
to heat, yeah.
and then sound.
Yeah, or sound. Okay, what's next?
State the principle of conservation of momentum.
Ah, boring. M1U1 plus M2U2 equals M1V1 plus M2V2, where you have to explain what each of the M's are. If you don't want to do that, you can just say in a closed system, momentum is conserved. There you go.
That's all.
Yeah, I don't think there's much more to add. I could flash it out and say is conserved between collisions, but it's unnecessary.
Carry on.
I'm not sure actually, Dorian, if it's closed or isolated. I can't
Well,
remember.
I think it's
You think it's what?
It's a
Either or.
I think there's a subtle difference between closed and isolated.
I think it's closed.
Anyways, it's a definition. You can check it.
It's closed doesn't mean that it's isolated.
Yeah.
That's what it's
It's the same.
I'm not convinced, but okay, we'll go on.
Okay. In a laboratory experiment using an air track, vehicle A of mass 0.6 kilograms, traveling at 0.65 meters per second,
Yeah.
approaches vehicle B of mass 0.5 kilograms,
Yeah.
traveling at 0.88 meters per second.
Yeah.
When the vehicles collide, so that's in the opposite direction.
They're both. It's like this.
Yeah.
Yeah. They stick together.
When the vehicles collide, a pin on vehicle A
Yeah. Yeah.
stinks into a lump of plasticine on vehicle B so that the two vehicles are held together. Determine the speed of the vehicles immediately after the collision.
Boring. M1U1 plus M2U2 equals M1 plus M2V. So divide by 1.1 and away we go. I sounded a bit like Rick there.
No, you have to put it in
I do, yeah.
I saw that I was watching it yesterday and the season 4 is not on Netflix yet.
Yeah. You have to get it from other websites.
Yeah, I know, but why?
One is closed one.
Negative 0.032.
Negative 0.032
318.
318 meters per second. Okie dokie.
What? How did you
Am I-
get that doing?
I think I didn't
Plus
do
it,
it, yeah.
you plus it.
So is it?
I don't know. I think it could be negative.
I got
Or
negative 0.45 recurring.
What? No, but you.
0.6 times
0.5.
0.65 plus 0.5 times negative 0.88 over
Oh,
1.1.
Oh wait.
Negative 0.45 recurring.
4545 or 555?
Yeah, 4 to 5 recurring. So
I typed in the wrong numbers.
So it's 455?
No, 0.44. It's
Yeah.
4545.
Oh, I see. Okay, okay. Da, 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 da. So that is minus 0.455 meters per second. Right, what's next?
Determine the direction of motions of the vehicles in
Determine the direction of motion. They're both heading left because it's negative. Is that like one mark?
Yeah.
Duh.
Sorry, this question is really bad.
Me do physics. Right, next one.
In a second experiment with the same air track and vehicles, vehicle A is fitted with a stretched elastic band on its front end. Is traveling towards vehicle B, which is fitted with a probe that hits the band as the vehicles collide and then separate. Just before the collision, vehicle A is traveling at 0.43 meters per second.
Okay, let me draw that. So, what did we say the mass was? 0.5, isn't it?
Yeah.
For A.
For A, it's 0.6.
Oh, 0.6. And its speed is, what did you say?
0.43.
0.43 meters
And
per
that
second.
one has the elastic band on it.
Like in front of it?
Yeah.
Okay.
No, like, I guess, so when the probe on the other one hits it, it's going to rebound.
Okay, whatever, continue.
some elastic band. Then vehicle B at 6.2 meters, 0.62 meters per second.
To the left.
Yeah. Immediately after the collision, vehicle A moves backwards at 0.5.
Ah, okay, so it's just like two rubber bumpers, and this one afterwards moves back at 0.
0.524 meters per second.
Yeah.
Show that this collision is almost elastic.
Okay, whatever,
5
dudes.
knots.
Whatever, dudes. Right. Okay, so we don't know the speed here, right? So let's get that first. We know the story here. M1, U1, so 0.43 times 0.6 minus 0.62 times 0.5 equals minus 0.524 times 0.6 plus 0.5 V. So then V will equal 0.43 times 0.6 minus 0.6, what was that? 62
Why
times
62?
0, was that speed? 0.
It should be negative, yeah. Negative.
Yeah, 0.5 plus 0.524 times 0.6 all over
0.5.
0.5. Now, what do we get here?
Zero point five two four eight.
0.5248
Wait, what?
meters per second.
No.
No?
I got the. I got
Seems
the-
a bit big,
Oh,
Zach.
no,
Yeah.
yeah,
Is
yeah,
it this?
Yeah.
Yeah, yeah.
So, how do we check if something's elastic or inelastic? Do we remember? The which, yeah?
Energy.
Energy, yeah. So, let's have a look now.
Wait, is that right, Warren?
Yeah. The kinetic energy at the beginning, we'll write it as KE1. That's a half m v squared plus a half m v squared equals, okay, when you're ready. And then the kinetic energy afterwards, that's a half m v squared plus a half m v squared. So what's the first one?
Shouldn't the 0.62 be negative?
Doesn't matter, it's being squared.
Alright.
I saved
The first
seconds by not writing the minus.
The first one is 0.15157.
0.15157
157.
It is. It is.
joules. And then the second one should be a little less.
Zero point 1512.
0.1512,
1512.
Yeah.
Yeah.
which is less.
Yeah.
So KE2 is less than KE1, which means it is inelastic, but almost
Why
elastic.
did they say all
I
that?
don't know.
That's it. Pretty easy, actually.
Yeah, in fact, if you were to do three significant figures, you'd still get 152 and 0.151. Okie dokie. Was that it for that mechanics question? Yeah?
On those questions, do we also have to give three significant figures? Or not? Like, because it's not really an answer.
Yeah, that's why I didn't. I left it as 4 because you're right, it's not really an answer. Yeah. There was one question I was looking at earlier today, actually. It was a mechanics one. I think it'd be good if we do it now.
Which one?
I think it was the most recent one.
So
Eight.
1819.
Uh-oh.
That's you. That's
There's
imagine
only
the.
one.
There's only one, correct.
There's only marking scheme.
Yeah, yeah, but the questions are in it, so.
Ah,
V3.
Question B1.
There was one with a circle.